Hello everyone, wishing you all a very good time. I Harshit Dixit, welcome in Harshit Dixit coaching. Now we will be studying motion in one dimension, part 11 of it, and in part 11 we will be studying relative motion. In relative motion we have two categories. First, the bodies which are in contact, and for non-contact bodies. First we will see what are the rules to be followed for contact bodies in contact. First we are taking the case for the same direction. These are the two bodies kept. This is body A and this is body B, which is kept over body A, and it is in complete contact with body A. Let us assume that the body A is moving with a velocity of VA and the body B is moving with a velocity of VB. Now, when such is the case, then the relative velocity of B or the net B with respect to A, or the net velocity, is always the summation of the two, VB plus VA. And the second case is for opposite direction. Suppose this is the body A and moving in direction VA in this direction. This is body B moving with velocity VB in that direction. Then the net velocity of B with respect to A will be VB minus VA. It will always be a subtractive one. Means if the bodies are in opposite direction, then it will be a subtraction will be there. Now let us come to the case of for non-contact bodies. Here we will be first taking the case of for same direction. Let us assume that this is a body A moving with the velocity VA in this direction, and this is body B moving with velocity VB in this direction. We are required to find out the velocity of B with respect to A. Then the methodology that is adopted is, suppose we have to find out the velocity of B with respect to A. So with respect to whatever we are finding out, we will make that body stationary. So here we are finding out with respect to A, so we will try to make the body A stationary. Now how we will make the body A stationary? Since the body A is moving with a velocity VA in this direction, so we will impart a velocity VA in this opposite direction. By imparting this velocity VA, this body comes out to be in rest. Now this is equivalent to this diagram, that this is the body B, this is the body B kept over here, this is the velocity VB acting on this side, and this is the velocity. Now this VA can be transferred over here. This VA can be transferred over here. How can it be transferred? Because we know the vector law, it says that a vector can be transferred parallel to another point of action without changing the original effect. What does this say? Suppose this is a point of action 1 and this is a vector A. Now I can transfer this vector to another point of action 2. Parallelly we have to transfer without having change in the effects. Right, so we have transferred this VA over here, and this body A becomes stationary. Now we can apply the law of vector, assuming that this direction to be positive and this direction to be negative. Now since this direction is positive, so VBA will be VB minus of VA. Right? So we have seen that if the two bodies are in the same direction, then the velocity of B with respect to A is always comes with VB minus VA. Let us take the another case for opposite direction. Assuming that these are the two bodies A and B, body A is moving with velocity VA in this direction and the body B is moving with the velocity VB in this direction. Now we have to find out velocity of B with respect to A. So the methodology is that since we have to find out with respect to A, so we will try to make this A stationary. And how will it be made stationary? By imparting a velocity VA in the direction opposite to the given velocity VA. Now this can be converted, this is equivalent to, this is body B, right? And this is the velocity VB, this is the velocity VB. Now VA can be transferred by this law over here. So I am transferring this VA over here, and this body becomes stationary. Body A is stationary. right? So now we are applying the vector law, right? Adding, assuming this direction to be positive and this direction to be negative. Now see, velocity Vb plus Va, since both are in the same direction, so what we will do, Vb plus Va. So we see that if the two bodies are in moving in opposite direction, then the net velocity or the velocity of B with respect to A is always an addition, Vb plus Va. Now we will see the question based on body in contact, which will make the concept clear, and then we will see the question on body for the non-contact bodies. So first let's start with the question with the bodies in contact. So let's start with the question that will give the clear view about the relative motion for the bodies in contact. This is the question which has come in NEET 2017. The question is, Preeti reached the metro station and found that the escalator was not working. She walked up the stationary escalator in time t1. On the other days, if she remains stationary on the moving escalator, then the escalator takes her up in time t2. The time taken by her to walk up on the moving escalator will be. So answer options are this. Now before proceeding for its solution, please see the video which will give you about how the escalator works. Then it will be very easy for us to understand the question. So please watch the video. Welcome back. Let's see the question. Preeti reached the metro station and found that the escalator was not working. She walked up the stationary escalator in time t1. On the other days, if she remains stationary on the moving escalator, then the escalator takes her up in time t2. The time taken by her to walk up on the moving escalator will be. This question seems to be long. It has come in NEET 2017, but it's a very easy question. Just see, there are two cases. The first case is, let us say this is an escalator of length d. This is Preeti standing over the escalator. In case number 1, it says that escalator velocity is 0. It is stationary, and Preeti is moving with the velocity, certain velocity in time t1. It covers the distance d in time t1. Let it the velocity be of Preeti be v1 for in this case. Now case number 2, on the other days, where she says on the other days if she remains stationary, means this is the escalator of length, same escalator of length d. This is Preeti standing over here with 0 velocity. Now escalator is moving throughout the length d, and in time t2, let the velocity be of the escalator be v2. Now they are asking the time taken by her to walk up on the moving escalator will be. Now this is the case 3, where the escalator is also moving with the velocity v2, and the Preeti is also walking with the velocity v1. Now they are asking the time taken by her to move up on the escalator will be, to cover the complete distance d, right? So for the case 3, if we talk about the net velocity, the velocity of Preeti with respect to escalator, or the net velocity will be equal to v1 plus v2. Why? Because since both are moving in the same direction, and since it is a case of body in complete contact, so according to this, what will be the velocity will be added. The velocity of the two bodies will be added to give the net velocity. So v1 plus v2. Right. Now what is v1? V1 is we know that velocity is defined as we know that velocity is defined as displacement upon time. Right. So velocity here, what will be the displacement for v1? It will be d will be the displacement for Preeti. And what will be the time taken by Preeti to walk the distance? D is t1. So d upon t1 plus for v2, if we talk about this is v2, the distance covered by the accelerator will be d. So this is d, right, upon the time taken by the accelerator is t2. So this is t2. So this is the net velocity. Now since they are asking for the time, so the net time will be given by the displacement upon the velocity, net velocity, it is vpe, right? Now displacement will be the same. It has the accelerator and Preeti both will cover the same distance d. So so here we can write displacement as d, right? And vpe, what is vpe? It is d upon t1 plus d upon t2, right? Here we can take d common, so this comes out 1 upon t1 plus 1 upon t2, right? So d and d cancels out. We can take the LCM over here. We can take the LCM. t1 t2 will be the LCM. So t2 plus t1 whole divided by 1, right? I can transfer t1 to t2 upside. So this will give t1 t2 upon t1 plus t2. So this is the answer, and we hereby go by option number B. So option number B is the correct answer. I hope the concept is clear, and this question and the relevant concept is correlated, and I hope the concept is clear. The next question that we will see is about for the bodies on non-contact type. Welcome back. Now let's see the question which is related to the bodies of non-contact in nature. This question has come in NEET 2009. The question is: a bus is moving with a speed of 10 meters per second on a straight road. A scooterist wishes to overtake the bus in 100 seconds. If the bus is at a distance of 1 kilometer from the scooterist, with what speed should the scooterist chase the bus? Now see, this is a bus, this is a scooter, right? Now the bus is moving with a velocity of 10 meters per second as given in the question, and this is we don't know the velocity of scooter, so let us assume it is to be vs. The distance between the scooter and the bus is given as 1 kilometer, so that will be 1000 meters. Right. Now the question is what velocity should the scooterist move to cover the distance of 1 kilometer in time 100 seconds. So since we have to find it for the scooterist, so we will find the velocity of scooterist with respect to bus. Right. Now as in the question, as in the concept, we can see if both the bodies are moving in the same direction, and the velocities are subtracted, and this minus sign comes with respect to what we are finding it out. Since we are finding out with respect to bus, so we will write it over here as vs minus of vb. And now vs is what is vs? Vs we have to find it out, and vb is what? 10 meter per second. So vs minus 10. Right. Next is what? Now we know the concept that velocity is equal to displacement upon time. Displacement upon time. Now what is the displacement? The scooter has to cover a distance of 1 kilometer, that is equal to 1000 meter. We will take it in meters because the all the answer option are in meter per second. So here we will take 1000 meter upon the time. Time is 100 seconds, so this is 100 seconds. Now velocity is what? VSB. We will take the velocity as VSB. Right. Now we have to find out, we will put the velocity VSB over here. Vs minus 10 is equal to, we can cancel it out, so this gives you 10. Vs is equal to 10, comes out to be 20 meter per second. So this is the velocity, this is the answer. So answer option goes with the D option. D is the final answer. I hope the concept is clear and we can relate the concept with the question. That's all for the today's lecture. Thank you one and all. Please like, share and subscribe the channel. Thank you one and all. Thank you.